I did number 2 and number 3. I did not do number 4.
Okay, I'll do 4 today. And if you want to see the modifications, what Bonnie did, go find Bonnie, go see her and see how that works. Because
And I'd just like to add, if you guys have any particular questions from the homework, shoot me an email.
There you go. She's always waiting for to help all of you in whatever time frame it works for both of you, her and you personally. And I'm sure she's willing to meet with you as a small group. If there's a couple, 2 or 3 of you that have developed relationships because of the little baby quizzes, and you are working outside, you have each other's phone number and things like that, that if Bonnie knew that, hey, there's 3 of us we have the same kind of issues, or we want to practice some problems before the next exam, she can and would do that like a little small group instead of one-on-one outside of her normal times, because she meets here. What is it? It's 9 o'clock. So 8:30, is that right, Bonnie? Right before class. That's on a regular basis. And then there's that window of time after I'm done that she's there for a period of time. And sometimes it's shortened because I've given you a little daily quiz, like today, for instance, it'll be shortened, but she's always there. And she wants to help you. But outside that, she's offered to help you if you need it. So there's a pitch for Bonnie. So she did this. Go ask her about it. These are kinds of problems out of this section 2.2. Guarantee there's going to be something, or maybe even a couple things, as word problems in your next exam. Maybe even your group quiz as well. So guaranteed. Something else, let's see, we talked about, looks like topics, minimums and maximums. These are parabolas that you guys looked at. We call them quadratics, but they're still polynomials. See, our next section is called polynomial functions. This is a polynomial function. It's just a very special one. It's called the quadratic function. Domain and range looks like we looked at. Vertex, how to find the vertex by hand, or the algebra, the little formula. Using your technology, we did that as well. 2 different versions of the standard form. 2 different versions look like this or that. This is nice. When I say nice, this is familiar because it's the quadratic formula form, right? If you set this equal to 0, it finds your solutions, which, by the way, if they're real solutions, what are they on your graph? If they're real solutions, what are they on your graph?
Points
every time. Say it one more time, Devin.
Points of the line.
Well, this is a curve.
The point, well, oh yeah, well, points of the parabola, or points of the curve.
Okay, where are the points sitting? Say it again. Somebody else was chiming in.
All real numbers.
Well, okay, I'll rephrase my question, or try to phrase it again. When I set this equal to 0, set it equal to 0, and you use quadratic formula on it, or if I ask you, hey, solve the darn thing with quadratic formula, and the results are real numbers, not imaginary, they're real numbers. They're very special, and you get 2 of them, by the way.
X-intercepts.
That's it. There. Okay. So thank you, Devin. That's what I was leading you towards, and I didn't do a very good job asking it the first time. So again, quadratic formula is parabola. True or false, all parabolas have x-intercepts. True or false, all parabolas have x-intercepts.
False.
Well, that's false, right. On occasions, usually wouldn't be a group quiz, but on an exam, sometimes I have true or false questions. That's a really good one. Those kinds of true or false, all, that's the key, parabolas or quadratic functions, all quadratic functions have at least one x-intercept. And that would be false. Okay, here's a different phrase. True or false, some quadratic functions have only one X-intercept? See, you got to be careful in the wording. True or false? Some, not all, some. Now you got to thinking, okay, some, yeah, okay. Some parabolas have only one X-intercept. Some of you are gun shy. Is it possible the parabola just touches, just bounces on the x-axis? Is it possible? Oh yeah. So that's what I'm saying is there's only one x-intercept. Some of you are thinking, hold it, intercept means it goes right through. I get it. You know, passes right through the x-axis. I get the idea about the wording, the language. But let's just say the intercept is where the ordered pair, which turns out to be the vertex, by the way, just touches or goes through either one. So the answer would be yes. That's possible. That would be a true. Some only has one x-intercept. What if I said something about or asked you about that particular situation? Okay, it's got one x-intercept, therefore it's got one solution. See, intercepts are solutions. So what do you got to say to me though? Yeah, it's got one solution. And then you tag on a phrase to that. It's one solution. Okay, well, then you're going to learn in this course, in the next section or two, not only is there one solution, there's actually two. See, a quadratic tells you how many solutions you're supposed to find, how many answers. See, so a degree 2, like how many answers? Okay, how many answers am I supposed to find? 2. 2 solutions, 2 answers. Could they be x-intercepts? Could they both be x-intercepts? Could it be you got one x-intercept? Well, then what's the other solution? Can't be imaginary. Imaginary solutions with no exceptions always comes in pairs. So it can't be one imaginary because it has a sister one. It can't be you get one imaginary, you get 2. So how can you have 2 solutions and one is the x-intercept? You're going to learn language coming up, might even be in this next section, that will say you've got a, sometimes they use the word double. It's a double solution, or it's a repeat, or they'll use its multiplicity 2. So if it's the x-intercept is, what is it, 1, 0, that would be an x-intercept. So x equals 1 is a solution with multiplicity 2. That means you've got 2 x equals 1s. Sounds weird, I know, sounds weird, but it's true. And you'll see that in either 2.2 or 2.3. Okay, so parabolas, imaginary numbers. You guys dealt with imaginary numbers, and we're going to be doing more of that coming up in the next 2 or 3 sections as well. So it looks like I'm going to do, because it looks like I did everything else. Oh, I didn't do this one. Okay, fine, I'll do this one. Whatever this one is. What is this one? Well, let's find some stuff. It feels like I ought to, and I'm going to, rearrange the terms. Let's make that y equals, because it's the same thing. I know it's a parabola. Okay, so it opens up. How come? Because the a is greater than 0. The a is positive. So what's my a? Oh, it's right here. A is 1. Okay, so I know it goes up. All right. How about vertex? Let's try to find the vertex, Vertex. Okay, there, it's an ordered pair. I'm just going to use my technology. Might as well. You're going to have that accessible for everything this semester, so why not? Doesn't matter how you type it in, calculator will understand either version. Doesn't matter. So I'll do the bottom one here. Zoom standard. Okay, hey, I said it was opening up, looked like it did. Let's see, looks a little fuzzy. Fine, let's do this. That's better. All right, well, things about this, I see that there are two X-intercepts, of course. That means there's two real solutions, There is a vertex I need to find. I can talk about intervals which is increasing, decreasing. I can talk about relative mins and maxes as well as absolute mins and maxes. That's all that stuff is old chapter 1 stuff for you. I'm going to find the vertex just to remind you how to do that. Let's see, vertex is either the min or max. It's the min in this case. Left bound, I'll type something over here. My vertex is right there. I'll type something over there, which is maybe -6. Vertex is still right there. Right of there is maybe 6. Yes, of course. Answer is trying to say -2, -5. It's trying. So I think it's -2. Vertex is -2, -5. So increasing. Well, increasing is this way. So, oh, okay. And it's two things. It's always the X value and it's always open parentheses, always. So it's the X value, so a -2 to infinity and always open. So therefore decreasing is -infinity coming from the other way up to -2. And constant, if we are dealing with constant, that's where it's flat. And there is nothing here that's flat about the parabola. Okay, how about y-intercept? Picture-wise, looks like it's in there somewhere. So y-intercept isn't x0, and the answer is yes. Y-intercept is when x is 0. I can go over here and just say, gosh, let x be 0. Y equals, when x is 0, 0 squared plus 4 times 0 minus 1. Oh, the y-intercept is -1. Or 0, -1. Could have looked at the table of values and seen that if it's possible. There it is right there, 0, -1. Now, if the y-intercept, at least in my table of values, the way I've set up my calculator, wasn't a nice integer. Integers are nice counting numbers, positive and negative. If it was a fraction, it would not have shown up here. I'll take that back. Actually, it would have, because all the x values are integers, and for the y-intercept to be found, its x is 0. So it would have shown up, my mistake. The result, no, the result may not be an integer, it may be a decimal. Okay, that's what I meant to say, decimal. So you'd have to still use your algebra to find it exactly. All right, so I found that. What about the x-intercepts? And there's 2 of them. So I go over like this. I go back to the graph. I'm going to go second. Well, I can do second table and see if I can see x-intercepts is where there's 0. When the y is 0, my mistake. I don't see where y is 0. So it must be some weird number, and only the quadratic formula is going to find it. So that's why I'm saying the quadratic formula right here is going to take this and set it equal to 0. So you find this by taking x squared plus 4x minus 1 when y equals 0. And so therefore you'd have x equals the opposite of b plus or minus the square root, and so on and so forth. You've done all this before in the past, this semester, at the beginning of the semester. And then you go the opposite of b. Okay, right here, what's A is 1, B is 4, C is -1. The opposite of 4, plus minus, square root, 4 squared. Okay, 16 plus 4, 20. All right, now you think the answers in the back, well, yeah, in the back of the book, as well as your multiple choice answers on the test will look just like that? They'll ask you to simplify. Okay, let's see, that's -4 plus or minus is a perfect square in there, which is 4 times 5, 4. So that would be 2 root 5 over 2. Okay, Jeff, that must be the answer that I'd find in the textbook or the multiple choice. Nope. You'd have to reduce or simplify. And this is where I know that some of you, even here today, are going to make the careless mistake. So hopefully you don't, but guaranteed somebody's not paying attention or they don't get it and they're not going to ask any questions. I'd like to think all of you are going to get it. Bonnie, isn't there, I don't know if it was you or Jan, that I said, okay, let's make this bet. And either you or Bonnie, Jan says, I'm rooting for the students.
Yeah, that was definitely
Everybody's
me.
going to get it. I can't remember what it was in our class.
That was me.
Yeah, I can't remember what.
Oh yeah, did I write down what that was?
Okay, well, I forgot. Here's another one, Bonnie. If there was a problem that led to this kind of scenario, I would bet that there's going to be at least one person here today, at least one. That means it could be more than that. That's going to do the following. They're looking at this and say, hey, 2 goes, no, well, they one of 2 problems. Hey, the 2's cancel. Therefore, the answer is -4 plus or minus square root of 5. You know what? And that'll be on the choices of the multiple choice, because I know, and the computer knows, your mistakes, the careless mistakes. I know that that's not right. Oh, okay, Jeff, that's not right. Oh, must be right if you just go 2 into 4, and so you get -2 plus or minus 2 root 5. Yeah, well, another mistake. But that answer will be on the multiple choice as well. So what's the correct answer? Well, what leads you to the correct answer? You separate this out just like imaginary numbers. You were taught that by me and Bonnie. Remember the A plus BI? It's been 2 weeks, Jeff. I haven't done those. Yeah, well, A plus BI, if there were fractions, I trained you, taught you, hopefully you remember by the exam, that you always separate things out and you reduce it. So I'm going to separate that out into 2 fractions, then reduce. So what am I going to do? I'm going to go negative. So this is x equals -4 over 2 plus or minus 2 root 5 over 2. Oh, yeah. And then you reduce. It feels just like the imaginary number process that we did before. And even if there was imaginary numbers, like if there was a negative in here, you'd pull it out as an I. The textbook gets weird. They oftentimes put the, did you recognize that, Bonnie? That the I goes in front of the radical sign?
Yes, some students brought up that it was that way on the, I think it was the last daily quiz that they had, that the test bank had the answers with the I in the front instead of in the back.
And you have a reason for that, Bonnie? Would you have an explanation to the students why that might be done?
Well, just from personal experience, I don't always write super neat. So I think it could be ambiguous whether the I was maybe under the root sign or where the I is ending up. I don't know. What are your thoughts on that one?
You're spot on. If you went square root of, say, -2, so 4 plus or minus, let's see, that comes out as an I. So, square root of 2I, that's bad. But that's what Bonnie's saying. You get sloppy. You can get sloppy. That's not good. If you went 4 plus or minus square root 2 and kind of be careful, put the I over there, that's good. That's what it's supposed to be. So what Bonnie, you use the word ambiguous, right? It could either, which one is it? Like that? Yeah, that's not right. That's good. So what the author does, probably most authors do, to avoid that ambiguity, the issue, they put the I in front. So this could be in the back of the book, and even in the author's multiple choice, it could be the I is right here with the square root of 2. It could be. Now, I was training you to always write it like in the group quiz. On the group quiz, I don't want it like that. I don't want it like that. I want it like that. And if you get sloppy on me like this, particularly this, you get sloppy on me, I'm going to take something off. I'm going to take a point or 2 off, and I'll say sloppy, not good. So just be careful. On the group quiz, yes, that's it. On the exam, could be, that's the choice. Could be. All right, so back down here then. Okay, what are we going to do? Reduce, you got x equals -2 plus or minus root 5. Okay, you got 2 answers. And if I did the decimal approximation to both of those answers, it would lead you to the decimal approximation to these guys right here. It would. Okay, what else is there to address? I think that's the general idea. So I'm going to stop right there. I'm going to go over to that word problem, and then we'll get started on the next section. So I think there's a rain gutter problem or two. I don't know if I gave it to you, but since I give you one here, it's up for grabs. I'll say that anything I do in my packet, even if I don't give you homework problems on, anything that's like it, I can give you.
Hey, Jeff, can I make a small suggestion on the last problem?
Yes, please.
You went through finding the vertex using the calculator. And then on the previous page, you have a way to find it not using the calculator.
Yes.
Using the x equals minus b over 2a. I was wondering if you might want to run through that for that example.
Do you have your document camera on you right now? Is it on?
No, it's not on. It would have to warm up.
Okay. And speaking of which, about the document, just say when I meet with you after class today, this wasn't what I wanted to talk to you about, but I want to add this now. Just say the word document camera. Jeff, you said document. Thank you.
All right.
All right. So yeah, the formula for finding the vertex. Now the vertex is X, but it's a very special letter. They call it H. And it's the formula, the opposite of B all over 2A. So it's on the previous page. Oh, what am I? I'm targeting my vertex is -2. That's what I found with the calculator. So if I plug it in here, X equals or H equals the opposite of B. Now, you don't know in this form right here, you don't know what B is. So you can't work this one with a B, only this version right here. But you know what? This version is actually giving you the vertex anyway. So, I mean, look at that. Change the sign, keep the sign. But in this one, your B was, let's see, B was 4. So the opposite of 4 over 2 times A is 1. -2, -2. 4 over 2 is 2. Well, there you go. And how do you find the -5? You go back over here and plug in -5. Excuse me, plug in -2. X is -2, and then find your Y, or G of -2. So if you go G of -2, which means I wonder what my Y is when X is -2. Yeah, maybe this is a good idea, Bonnie, because this is an easy mistake. Watch this. I'm not going to make this bet because I think most students probably even writing it incorrectly, Bonnie. Here's incorrectly. You know, x squared, okay, -2 squared. They write it incorrectly on that one, and then they still make it +4. So I've seen that most of the time. They write it wrong, but they get what it's supposed to be. That's written wrong. It should be this way. Okay, so whatever x is, the whole thing is squared, and then plus 4 times, and then -2 again, and then we got subtract 1. Okay, that's 4, subtract 8, subtract 1. That's -4. Okay, that's -5. Ding, ding, ding. There it is.
Thank you.
I'm not going to make that bet, Bonnie, because I think most of the time, you know what happens if they do it this way, which is good on the group quiz, but they don't put the parentheses around it. Sometimes I ding the students because I call it sloppy math. Did I use that phrase when you took my class, Bonnie? Sloppy math.
You definitely talked about that a lot. I don't know if you used the word sloppy. I think you probably did.
Yeah. Sloppy math. Where's my square root thing? Yeah. Sloppy math right there. I use the word sloppy, at least in my algebra classes. I'm not sure in my pre-calc, but so yeah, I get picky on the group quiz. Or if it was a regular exam, face-to-face, show me the work, I grade it, get partial credit. Yeah, I take pieces off, points off, and it hurts a lot of people. Sometimes it's almost a whole grade of sloppy math. To me, it's important. All right, let's see how we're doing on time. Okay, that was a half hour. Okay, I'll go through this. Rain gutter problem. Okay, you got a rain gutter made from sheets of aluminum that are 12 inches wide, turning up the edges to form right triangles or right angles. There are mobile gutter companies. They have trucks with a trailer. You might have seen them around somewhere. They pull a trailer with this ginormous wheel of sheet metal or aluminum or whatever they make it out of, and the machine bends it, folds it, creates seamless gutters on site. So I can only imagine that this is kind of like a problem, you know, that I might have created from that example of what I saw. And you'll see a rain gutter problem. Oh, I was going to show everybody in your textbook. Uh, 2.2. Hello. Okay, here's problems that are like the ones that I did and Bonnie did. These guys right here. Okay, so more and more. Similar, not rain gutter problems, but similar to the previous problem, similar. Oh, rain gutter. Oh, rain gutter. So there's 2 of them. I don't know if I gave you any in your homework. I'd attempt them, but maybe I did. I don't know. Rain gutters made from sheets of aluminum, 12 inches wide. Okay, so I see it as sheets of aluminum. Okay, so here's a big sheet of aluminum that goes on forever. It's like when it takes it off the truck, it's a big flat sheet of aluminum, and then they're going to turn up the edges to form right triangles. So this is 12 inches right there. And they're going to turn up the edges. So like this here. So they're going to bend the edges. Let's assume that the edges, and I think that's what this is asking, that the edges are symmetric. It's not like the back edge is longer because you're trying to attach it to the roof. The front edge is lower. Let's assume it's symmetric. So this is the bottom of the gutter, and this will be turned up so it's an edge, and this will be turned up that it's an edge. Then it talks about a cross-sectional area. So if you took the gutter, I don't know if I forgot to bring my scratch paper. I can do it with this one. All right, so you got a piece of paper like this. It's like a piece of sheet metal. And then you cross-sectional. Oh, there. Okay. That's the way I'm going to draw my picture. That's called a cross-sectional. So if you chop it off like this, you're looking at it this way. So here's your cross-section. All right. Determine the depth. Well, that's right here. The gutter. Okay, what is that? I don't know. Let's call it X. Determine the depth, X, which is the same as over here. So that the cross-sectional area, that means this area. Now the water is like flowing right here. Flow, 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 flow. Greatest amount of water flow. So I need the area right here. So it's like a little rectangle. We've done rectangles before with the pen or the I don't know, the corral or whatever you want to call that. The playground, something like that. Fencing, rectangles. Okay, I guess we'll call that Y because I need another variable. So in like manner, we had two equations. So you need one that utilizes the 12. Now the 12 is straight across, which is the 12 is all the way this. That's the 12. So I see it as 12 is equal to 2 the X's and a Y. That's one equation. And the other one, which is what you need for your graphing calculator, because whatever you're maximizing, that's the equation you put in your calculator. I'm not maximizing this, I'm maximizing the area. This is your area. So area equals X times Y. And so what I do is solve for one of these variables. Looks like a Y is a nice one. Solve for Y, plug it in over here like I did the other problems. So I have Y equals, was it 12 subtract 2X? Put it over here, so you get area equals X, 12 subtract 2X. And put that in my calculator. And when you're looking at maximizing, let's see, maximizing, it better be a parabola that goes like this. If you're maximizing, it better be a mountain. Oh, look at it, it will be. If I distribute the X over here, that's going to be negative 2X squared. So it's going to be a parabola goes down. Okay, so we go Y equals, get rid of that thing. X parentheses 12 subtract 2X. Zoom standard. Okay, but I need to see the vertex, so I got to go higher on my calculator, higher. Okay, window. I'm choosing to do window. Some of you might do zoom out, or there's called a zoom fit. Now that's interesting. I'll show you right here. Sometimes zoom out works. Sometimes there's a zoom fit. If you scroll down here, I don't like using it because sometimes it's crummy. Zoom fit actually, Bonnie, works pretty good for the trig. We don't have trig in this one, but zoom fit or even zoom trig works really good for trig equations functions. But for functions like this, it's a hit and miss with the zoom fit. It's going to try to fit what the calculator thinks it's the best picture on the screen. So when I use this, I'll hit enter. Let's see what it does for me. I don't know what it does. Hey, that's not bad. See, I'm just trying to find the vertex, so it might do it. You know, it's a maximum. You say, well, that looks like a weird graph. Well, then use the window. Let's see if it gives me, because it's right at the top of the screen. I don't know if it's going to do it. Second calc, that should be a maximum. And then let's say it's a -5 and a, I don't know, +20. Oh, yeah, I'm off my screen. When I did 20, I was off my screen. So I got to do it all over again. Yeah, probably some of you are saying, yeah, I don't like doing this. Max 4. All right, so -5, and let's do 9. Yeah, that's okay. I can see my markers. I said 20 before, and I was off my screen. Hey, did it. It found it, actually. So 18 is the maximum square units, which is, I think it's inches. So square inches. And the depth, I think they're asking for the depth. You know, right there, the depth. Three inches. Okay, this is 3. This is 3. 3 and 3 is, what's that, 6? This has got to be 6. So the bottom of the gutter is 6 inches. If they're asking what's the dimensions, it doesn't. But ask for what's the maximum cross-sectional area. That is the Y value, which is 18 square inches. Okay, now let's take a look with the time remaining. And I got a little baby quiz with you too, I think. Time remaining, what the 2.3 is about. Looking to see how many pages. I don't think I had a lot of pages. Okay, it's 2.3, I said. Not 2.5, not 2.4. I'm working back. No long division yet. That's coming next week. Hey, I've only got 2 pages. No problem. Must be, if you were thinking only 2 pages, there's not a lot to it. No, there isn't, because you're going to use your technology for the most part to do whatever they're asking you to. I'm not looking for the algebra, just use your technology. All right, so polynomial function, turns out that the powers are all whole numbers, no fractional powers, no negative powers. The degree indicates the maximum number of, okay, as I said before about a half hour ago, real zeros are X-intercepts. Real zeros are X-intercepts. Imaginary zeros or imaginary solutions are not X-intercepts, they're just solutions. So if I look at this, this tells you, I could have, it says maximum. There could be less. I could have 2 X-intercepts. I might have 1 X-intercept. I might not have any X-intercepts. And if I have no X-intercepts, but there's 2 answers, they would have to be imaginary answers. They'd have to be, because they come in little pairs. And the only way you can find imaginary answers is use a quadratic formula. Okay, and turns. You know, if it's, you got a degree 2, you know, it's a parabola. How many turns are there? If I have a degree, I don't know, 5, or like this one. No, not that one. Like this one. I have a degree 3 polynomial. How many turns could I have? I might have less, but 2 is the most number of turns. You can't have any more than that. Okay, a degree 4 polynomial. How many turns could I have, the maximum? I could do 3, one less turn than the degree. But how many solutions do I have, or zeros? Got to find them all. Go back over here, find them all. Sometimes factoring works. Find the zeros. That means you take 5x squared plus 6x and set it equal to 0. You could use the quadratic formula and beat this thing to death with it. I'm not. I'm going to do the factoring, which is x, 5x plus 6. Good to practice the factoring for you guys, because I don't know, depends on the instructor for your 1A class. Bonnie, did I think Tom Falbo was your 1A instructor, is that right? How much factoring did he use in I think you took it online, didn't you?
It was half online and then, you know, half in person, and then we had.
Because it was spring, that's right.
Yeah, it was spring.
So how much factoring, do you remember him saying factoring is important, or I want you to factor? Did he do anything?
Factoring is handy. Sometimes it can just save you a ton of time. So I don't remember it being emphasized specifically, but I know that it definitely comes in handy. So
that was a good answer. Yeah.
Good thing to be good at. It's a good skill to have for sure.
It could be handy, saves you time. I like that answer. Whether or not you get an instructor that says you need to do, like, it could have been Dave Olson. Could have been Dave Olson, kind of, you're going to do it the old fashioned way, screw the technology. I'm not saying that he said that, but I mean, old fashioned kind of way to do it. He could have been one that says factoring is needed, demanded.
We're actually doing a lot of complete the square right now with 10.5 conic sections in the 1B. So yeah, there's complete the square, and definitely some factoring involved with the formulas where you are rotating curves around the axis. It definitely comes back.
And sometimes it's a while, so you kind of forget, you know, some of these techniques. So as long as someone shows you maybe one example, and Bonnie would say, "Oh, I remember now." I forgot. She could do some research, probably look it up. All of you could do the same thing, and you'd get it. It would just take you a little time to remember. Find the zeros. That means you're going to take this and set x equal to 0, and you take 5x plus 6 equal to 0, and you solve for x. You get x is equal to negative 6 over 5. Okay, so there they are. They call them zeros, by the way. They're not going to call them X-intercepts. They're going to call them zeros. Call them zeros. Okay, how many zeros on this one? Well, I'll let you figure that out. I'm not going to do it. I'm going to do this one. This is kind of a weird one. Because of time, I'm looking at time. So I'll do this one and the last one. And Bonnie, maybe if you have time, you can go over this one. So I'm going to do this one, and I'll do the next one down below. Okay, so I think I'm going to go ahead and solve this with the calculator, Jeff. Or telling myself that. Hey, Jeff, couldn't you use your technology? You said we could. I did, didn't I? All right, fine. I'll go ahead and graph this. Okay, let's see. Let's do Zoom standard. Okay, there's one. There's one. That's weird. That's one of those bounces. Remember I said a parabola could bounce? That's a weird one. And there's definitely another one. So it looks like there could be 3. I wonder how many answers I'm supposed to be finding altogether. Called answers or solutions. if you foiled this out, you'd have a degree 2 polynomial times a degree 2 polynomial. 2 times 2 is 4. You'll have a degree 4 polynomial. You have to find 4 answers. It looks like there's only 3. So could you find those using your technology? Yeah, you know how to do that. I'm going to show you what happens about the fourth answer that isn't appearing there. All right, this is just write down x minus 1 twice. All right, this is another good example of factoring method. The last one I did was called greatest common factor. This one is a difference, fill in the blank. If I said difference, fill in the blank, you guys, probably most of you would say of 2 squares. I remember that phrase, difference of 2 squares or difference of squares. All right, x and x, a 2 and a 2 and a plus and a minus, you're done. Fastest factoring method out of all of them, in my opinion. Okay, I see 1, 2, 3, 4 little factors. 1, 2, 3, 4, that means 4 answers. If you get all of them factors into linear factors, degree 1s, degree 1, degree 1, degree 1, degree 1, then you've got all your answers. This is the funny thing here. If I set each one of these equal to 0, this is x is equal to -2. Okay, x equals 2. Okay, x equals 1, x equals 1. Oh, well, that's the same thing, Jeff. I know, but you have to account for both of them. So this is what you do. You either box this and there's your 4 answers and that bothers you, or you could say x equals 1. And then the author says, you use this phrase called multiplicity. There's 2 of them. So you'd say like with multiplicity, multiplicity 2 or TWO. And then you've got x is equal to 2, comma, and then x is equal to -2. Or you can go like this. That could be x is equal to plus or minus 2. I've seen that. Plus or minus 2. I've seen that. So you've got 2 answers and 2 more answers. You get the 4. I'm not going to do this one. Bonnie, don't. I think at this stage, if you do this one, I don't need the grouping. They have access to their technology. I think all of them will be there somehow. And this one here, you might want to remind them about the factoring. That's not a bad one. Grouping is hard. I really don't remember where grouping is really helpfully needed in any of your higher level math courses. For speed, grouping is just kind of messy. So Bonnie, don't use grouping. I'm going to leave that last one for you, and then leave the first one for you too, if they come today. Okay, I think that's it. I think the next page, yep, 2.4. Oh, well, that's interesting. Why is that 2.3? Yeah, that's right, 2.3. So 2 pages on 2.3, and I'm done. All right, here we go. I'm going to release your little quiz. Find it here somewhere. It's number 6. All right, I just published it. I need to see a couple thumbs up or shake of your heads that you found it. It's daily quiz number 6. Okay, thank you, Edgar. And I see Rochelle saying the same thing. So, and it's based on the quadratics only. Let me double check to make sure that's true. I have the example up here. Yep, all quadratics. Okay. So here we go. I'm done. That's all I have for you. Go see Bonnie if you have the time after this. Otherwise, I'll see you next week. So Bonnie, I have document camera first. If you come back and work for me as a pal in the spring, I've ordered, it's on back order like for 10 weeks. I've ordered a second nice little portable, looks like this, document camera that works for a Mac or it's a dual platform, Mac or a PC. So I've got a nice portable instead of a big clunky one that the JC gave you. So really easy to use. Plug and go. That's kind of what it does. So that's the document camera thing. And I'm not saying that to entice you, but and if it turns out that you head off to Boulder and it's before spring and you say yes to doing 1 or 2 classes, then we'll make the arrangements so I can get you the box with the document camera. And then after spring, since I'm done, then how you get it back to me, then we'll figure out what that looks like. You just might ship it to me and something like that. Or I'm driving to Tennessee and I pass by NZ.
Right. Pass by Boulder. Yeah. Yep. You know, maybe we'll be able to get in-person food, but
right.
Maybe.
Go to the Coors factory down in Golden, Colorado. We'll meet down there.
The Coors factory. Yeah, we can see where the magic happens. There's definitely a possibility. I've been thinking about it just, you know, since we were talking last, and there's definitely a possibility that I'm gonna just not try to work at all. I'm thinking about moving. I'm thinking about, you know, all the little details that come with moving, having to buy furniture and, you know, figuring out the lay of the land. So, I mean, I just, in the interest of transparency and good communication, there's a real chance that I'm going to sort of get to a point and go, okay, this is not adding up. And I probably,
in terms of your time, in terms of, you know, you're not getting paid a lot. I mean, it's like, what is it, $15 an hour or something like that?
$15 an hour, yeah. So it's like if I spent 40 hours a week working at $15 an hour, that would be like, so I have to find like the maximum. I have to maximize the parabola, right?
Right.
So for $15 an hour, it's not worth it.
I totally get
a lot of hours.
I totally get it. It may not behoove you to even do it and consider it. So
there's definitely a possibility.
So the sooner that you know and you feel like I've made my mind up, then let me know, and I'm good with that. And that way I'll know I'm moving ahead with those classes with no help, or I know that I have to find somebody else.
You can start recruiting another pal. Yeah.
Right.
Okay. So I will definitely give it some more thought. I just sort of realized like, oh, you know, there's a real possibility that I don't want to work at all.
Right.
You know, if I was going to work for somebody. And then there's the other consideration too. I mean, I definitely enjoy working with you, Jeff. So it's not that. But there's also the possibility that working in California could hurt my residency, because I'm trying to establish residency. That's the whole point of moving.
Yeah.
And it could really complicate things. I don't even know who to ask about these things. Like I've definitely had like financial aid questions about like FAFSA, and I don't know who to ask. I've asked the financial aid office, and they're not like, you know, like financial planners. They're not.
Do you have an accountant, or does your mom have an accountant? Do you have an accountant? Your mom? Does your mom have an accountant that she uses?
Yeah, she does, but I mean, she's emailed her and she doesn't know anything about FAFSA or student loans or, you know, that kind of like, it's a very particular branch. Like I just don't even know who to ask. So I just kind of wing it. And I'm thinking I'm thinking with as complicated as the residency requirements are, that it, I'm definitely going to be doing school still. So I'm still keeping like 1 foot in California. But, if I have multiple jobs in California, they're going to be like, are you really moving here? Or are you just, especially if I have to file taxes, on money that I've made in California, but trying to claim like Colorado as residency. I mean, it just sounds like it's going to get really complicated.
Well, it could, but think about how many people are working remotely.
Right now, a lot.
Right. And so I'm wondering that it's a moot point. Everybody in the world is probably working someplace.
Mhm.
Their job is elsewhere and getting paid from a different state or country.
Yeah.
It's just how you file your taxes. I don't know about residency, if it makes a difference or not, but that's something
Yeah.
you have to ask and find out and then make a decision.
Or yeah, exactly. So that's definitely a consideration as well. So I wanted to just, I have given it a little more thought, and I'll keep thinking about it, and I'll let you know as soon as I come up with a decision. And did you have something else that you wanted to talk about?
I'm
I feel
not
like
going to say it now because it was just more about spring. I had some
more about spring.
thoughts about what you and I talked about homework, but
Mhm.
I'm just going to say, if you're not here, then I'll go with my original plan. I get what you're saying as a student, not being motivated, but hey,
No, it's not just the motivation. It's about prioritizing things. And it's just, I mean, even just have something due like for 10 points, must upload a file. You don't have to tell them that it could be a blank piece of paper, upload 10 points, no upload, 0 points. Anyways, it's just, I just think about it from the student's perspective. For me, it's just, that's the reason that I'm doing this is because I want to help people succeed. I want to give people the best chance at success. And I know that that's why you've gotten into teaching as well. I mean, it's not because, you hate students and you really enjoy giving them Fs. And that's why you wanted to become a math teacher.
No.
Just so you could give out Fs. That's not it. So
right. Yeah.
I'm just thinking about it from like, especially because you're not going to be as available. What is going to be helpful to them in their success, considering that it's not going to be a face-to-face synchronous class, what would be at least kind of pushing them in the right direction. Now, we all know you can lead a horse to water. You cannot force people to do the work and learn the material. But, at least just setting them up with a couple tools.
So I would have done it for a different reason. That's what I was going to just kind of talk to you, brainstorm. So when you make a decision, then we can talk more about that. If you say, yes, I want to do it this way. But when I would have done it to benefit or to help you and Jan, so that you had people coming to you thinking they need help. So that you're not sitting there with nobody coming because they choose, there's no homework and I'm just going to do, So I would be doing it for you so that you have a purpose rather than just getting paid $15 an hour for doing nothing. So I got to thinking that would be a good reason is to
especially if there's another pal, that would be beneficial for them as well.
Yeah. Yeah. Okay. Looks like they're leaving. All right. Talk to you later.
All right. Bye.